Hello and welcome to some feedback on the Advanced Mathematics exam from 2021 on questions 13, 14, 30 and 33. My name is Graeme Harris and I was one of the senior markers for the 2021 exam. Now, question 13. Basically, we were very happy that most of the candidates that attempted this question realized that it was a product rule question. So that was a fantastic start from most candidates. And most candidates also recognized that once they'd gone through the product rule and differentiated, that they actually had to substitute in x equals pi on 3. So they were positives from the question that we looked at. A few of the common errors that were seen was when students were differentiating, they differentiated tan x incorrectly. There were many various different responses, but either way it was incorrect. Another error that we saw occur was that some students found the tan of pi on 3 and they actually used their calculator in degrees mode to come up with a decimal answer that was not what we were looking for. They need to understand that pi on 3 is in radians, so they need to be using radians mode if they're going to use their calculator. And we were after the exact gradient as well. Some students, when they differentiated tan x, got sec squared x, but didn't know what to do with it, didn't realize it was 1 over cos squared x. So that was another error that we saw pop up periodically. Remember that when you are dealing with a question that says find the exact answer, that's exactly what we want, the exact answer and not a decimal approximation. So that's something that students also should be looking for when they read the question. Does it want an exact answer or is an approximation appropriate? So the candidates are strongly encouraged, basically after looking at this question, to practice trigonometry using both degrees and radians and understand when to apply degrees and radians. Moving on to question 14. Question 14, we've got an arithmetic sequence and we're trying to, we know the sum, we know there's 43 terms, we're trying to find the common difference. Now, with this question, most candidates attempted to find the answer using the sum of an arithmetic sequence, which is fantastic. That formula is on the reference sheet. And whether they knew it off by heart or whether they referred to the reference sheet doesn't really matter. They chose the appropriate formula, which was great. Some students couldn't identify all of the variables required. So they may have recognized that A was 5, but they couldn't recognize one of the other variables, or they may have actually mixed variables up, which could sometimes obviously lead to errors. Some people actually had the correct variables, but when they were actually plugging those variables into the arithmetic formula, they actually made some algebraic mistakes and that led to a final result that was not correct. The candidates are strongly encouraged to actually know what is on their reference sheet. Now, I would often tell my students when I'm teaching something like this that realistically, if they don't know the sum formula for both arithmetic and geometric questions, then I haven't given them enough questions. But they are to know that it's also on the reference sheet if they needed to check if they were having a mental blank or something like that. We move on to question 30. Now, question 30 being in the second booklet, you'd obviously expect it to be a little bit more challenging and indeed it was. So we can see the question there. And one of the positives that came out of question 30 was that the candidates often began with the correct exponential equation. If they started with the correct exponential equation, they actually solved it correctly. So that was actually a good thing. Some of the common errors that we saw was students that did not have an understanding of what a cumulative distribution function actually is. It's a capital F where you see the f of x in the question. It's not a lowercase f. So we need to understand how that works if we want to be able to be successful in questions like this. And Also, when solving the exponential, some students didn't understand how to go through the process and introduce natural logarithms. With this particular question, it was pretty apparent that more students needed to practice cumulative distribution functions in a practical context and to know the difference between capital F of X and lowercase f of X. Moving on to question 33, Part A. Again, in the second booklet, you'd expect this to be a bit more challenging, and it definitely is a bit more challenging as a question. We have Part A where they have a show that question. So we can see we've got a probability density function provided, and we have to show that capital A is 2 over ln 10. Now, many candidates, I don't know about most, but many candidates recognize that the integral of the probability density function has to be equal to 1. So they set it up correctly as a starting point, which was a fantastic way to begin a question, setting it up equal to 1. Some students that managed to do that didn't integrate correctly, which led to errors. And another error that we saw pop up quite often was students that integrated correctly, but didn't put a bracket around the x squared plus 4, which meant that they had problems when they substituted in when they were going through the integration process. So I would be encouraging students to make sure they use brackets where appropriate. With this particular question, it's really important that students have a good knowledge of the logarithmic laws and how to apply them if they actually wanted to succeed. Moving on to parts, and that they should show they're working out in a clear and organised manner because it is a show that question. You can't leave out multiple steps of working out in a show that question. We also go on to Part B where it says show that the mode of X is 2 hours. Again, another show that question. Now, one of the positives for this question was many candidates recognised that by setting the f of x value or the derivative of f of x equal to 0, they'd be able to find a maximum. And that was a good start because a lot of candidates recognised that a derivative was involved for this part. Common errors included using the quotient rule correctly with the constant a. Algebraic errors, because actually I'll go back and just say using the quotient rule incorrectly with the constant a would have been a common error. I apologise for that dot point. Algebraic errors were often made going through the process because being a quotient rule question, it got a little bit messy. With this particular question, it is far easier, and it's actually a very valid question to actually run through with students for future reference. If they integrated the question using a as the constant and not substituting in 2 over ln 10 until later on in the question, it was actually far easier than those that substituted 2 on ln 10 in straight away at the very beginning of the question. So a very good practice question for students to understand that whilst you can still get the same answer, it's a far easier way to do it by not substituting a equals 2 on ln 10 up front. Now, as I said before, when you have a show that question, questions that start with a show require clear and logical working out in order to be able to convince somebody who's marking it that the student knows what they are doing. We're going on to Part C now. And with Part C, where we're showing that the probability that x is less than 2 is equal to the log to base 10 of 2, candidates that identified that there was a link to Part A, they were more successful than anyone else at this question, obviously, because they saw that link. There's a strong link to Part A for this question. Errors included not being able to identify the relationship between your PDFs and integration, and not identifying that the integral had to be evaluated from 0 to 2. You'll see that if you're going from x is less than 2, 0 up to 2 is where we will want to integrate from for this question. Some students when they substituted A equals 2 on ln 10 in, made algebraic errors because you had a fraction in a fraction, and they made mistakes when they were trying to simplify that. So with this question, again, a show that question. We know what the answer is. The student knows what the answer is, so they must show some clear working out that indicates they know how to arrive at the answer. Now, part D of question 33, one of these questions where there was quite a bit of reading there to try and interpret what the question was asking. Now, this question was a challenging question. Now, I don't know that that's a positive thing, but it's a positive thing that there are challenging questions on the paper, because it really sorts out those students who have a thorough understanding of concepts as opposed to those who aren't quite as sure. Now, some of the candidates looking at this question were able to look at the mean of 100 and the standard deviation of 15, and they were able to play around and generate that to have an IQ greater than 130 represented 2.5% of our population. That was actually a good start, but it wasn't enough to generate the question. Now, a lot of students didn't recognize this question as being a conditional probability question. If you haven't downloaded the examiner's comments and the sample solutions from NESA, I would suggest you do so, and you'll be able to see that this question is definitely a conditional probability question to do it correctly. Also, you needed to be able to recognize that the answer to part C was required because it was used in the conditional probability. With this particular question, the bottom line is it was extremely challenging, and many students found it challenging. Students would benefit from practicing complex conditional probability questions. Doesn't mean that there's going to be one guaranteed every year, but it would help them to understand this concept far better. So as I said before, strongly recommend downloading the NESA sample solutions and examiners' comments and feedback, and you'll be able to get more detail even then. Thank you for your time. Oh, again, this being a word question, very important to practice these types of questions to have a thorough understanding of what's going on. So thank you for your time, and hopefully you enjoy teaching in 2022.